Hello everybody, and my name is Sardor and I'm going to teach you about sensor fusion. So it's a very wide topic and be prepared to learn a lot of stuff. Why do you need sensor fusion? First of all, sensor fusion means combining data from several sensors to obtain some meaningful data that we can use afterwards. It's a very wide topic as it includes combining and knowing the sensors, their capabilities, their limits, advantages and disadvantages. Take a real life example. We have an autonomous car and we have a RGBD camera and laser distance measurement. So we have RGBD camera that has very colorful image and contain a lot of data, but it's not very reliable in the terms of safety and distance. So we refer to the measuring distance with laser or LiDAR sensor. Combining LiDAR sensor and RGBD camera, we obtain something meaningful and something reliable that we can use on to determine whether the vehicle is nearby and what actions we need to do. So knowing the limits of RGBD camera and knowing the capabilities and the advantages of LiDAR permits us to use this concept in autonomous vehicles. But there are much more of sensors in every industry and robotics applications that we are going to cover along the term. So be prepared. Today we are going to talk about sensor data preparation, pre-processing and post-processing. So what does it mean? Pre-processing may comprise a lot of things, but the most common is calibration and zero value footage. So by this I mean in every equipment, whether you buy it or you use it over time, the initial value of this equipment changes and it's not zero always. So when taking any measurement, you first of all you need to be sure that your equipment is at the zero value or zero volt for electronic sensors. In this case, if it is, you can take up other measurements. Otherwise, you need to go back and to calibrate it, to change the settings and to put it to the zero value, zero initial value. For instance, if you take example of scales for weighing, from time to time you see the value of not 0 kilograms and you need to put a hand and the screwdriver a bit to put the scales to the 0 kilograms to measure precisely the weight of yourself afterwards. In the electric sensor is the same. For instance, when taking a light measurement equipment, first of all we need to see in the darkness if it shows the zero value initial value. It's not necessarily 0 volts, it can be 5 volts and from luminosity it can diminish, or it can be 0 volts and from luminosity the value can increase. But the initial value is normally specified in the datasheet and you need to calibrate your sensor to this value. So after the preparation of sensor is done, you need to take several precise measurements and to post-process the data. So post-process the data is a very wide topic and it can take several hours to discuss it. It depends on the application, but in this lesson we are going to talk about general cases of any electric sensor post-processing. So if we take, for instance, an image from the RGBD camera, what are the steps required to post-process the data? First of all, we need to make sure that there is no noise and distortion in the image that we have taken. In the real world, not perfect. As we learned in the high school, we have always a white noise from various sources, and we need to eliminate it using various techniques and equipments. There may be some internal filters in the equipment using Chebyshev or Butterworth filtering for signal processing, or some image filtering considering the color, the contrast of the image, and doing interpolation for guessing the color and the contrast of the points that are noisy in the image. So when we have done the first step of post-processing, eliminating the filter, eliminating the noise and various data pollution, we need to post-process the data furthermore. If the data is distorted, if the image is distorted, we need to put it on our perspective, or to do a perspective transform using OpenCV or MATLAB as you want. Afterwards, we can do several things to post-process the data. It depends always on your application, but if you take, for instance, segmentation, what is actually segmentation? Segmentation is putting an object's data in several clusters that we think are united by some principle or function. And in the world, what can be segmentation in the world? It can be in any point at any time. For instance, if you take kitchen equipment, it can be segments, can be spoons, knives, and forks. In our data, in any data, there can be some groups of data that are united by some parameter. In the image, it can be color, it can be contrast. In the RGBD image, it can be depth, color, and red color, green color, or blue color, and so on. So there are many techniques for clustering, and some of them are the most popular are actually k-means clustering and dbScan algorithm. What is k-means clustering? K-means clustering is the algorithm that calculates the clusters given that you specify how many clusters we have in the data, and it also tells the outliers and edge members. So how does this work? You put, for instance, you specify n clusters, you put n points in the data, and it calculates the distance of the neighboring points, it calculates the cluster, and then it calculates the centroid of this cluster, and each time the centroid, every cycle, it recalculates, it takes as the points the centroid of the cluster, it recalculates the neighboring points that belong to this cluster, and it recalculates the centroid, and the clustering algorithm finishes when the convergence is met, or we take step limit for clustering. For instance, if we see that the boundaries of cluster don't move anymore, we can stop the algorithm, as it seems that all the clusters are determined, and we can process those clusters further. We can unite them to database, or we can use them in our programs. But in dpscan method, we don't specify how many clusters we are going to have, but we specify what are the minimum points or that we are going to have in a cluster, as well as the maximum distance allowed for points in a cluster. So how does it work? If it takes every point in our data, imagine that we have 2D data and we want to cluster it. It takes every point in the data, and if there is any point that is less distance than the max distance, it becomes an edge of the cluster, the point it finds in its range. If any point in the data has minimum number of points -1, at least minimum number of points -1 points that are neighboring to this point. By neighboring, I mean that they are on the distance less of the maximum distance. Then the point becomes the core point of the cluster. And like this, it regroups the data, and if a point doesn't have any other points that are neighboring to it, it becomes an outlier. So I think that's pretty much it. So in this lesson, we discussed the introduction to filtering and how the calibration works, the overall methodology, and we discussed more or less clustering and two methods of clustering, k-means clustering and dbscan algorithm that permit to cluster the data in the groups. So thank you very much. Next time we are going to see about Chebyshev and Butterworth filters for electric sensors and signal processing.